We have still a couple of groups who have not determined their own role and project repository yet. So it's a significant number of you. So please do this by today. Otherwise you would be in trouble. If you don't know what you're going to do for the project, then you will be in trouble. And as I said, the first group who returns the results of this project and does it correctly, at least in a meaningful sense, will get an A, regardless of whatever else they have done in this course. So the first group who gets this project done, yes, why not? So if you feel confident about yourself and in doing this project, and you think like you could be the first person, I would say you could drop anything else, all the homework, quizzes, don't worry about them, just focus on the project, finish it by Wednesday, and you will be the first person, and you will get an A. No, I'm saying by the time, so you should be the first person, the first group, not the person, because it's a whole group, right? So if you can manage your group to finish it as the first one, and you do it correctly, not exactly the same, but at least in my eyes it looks correct, then you'll get an A, regardless of what you have done for the rest of the quizzes, homework in this course. Okay, so again, don't forget to add your leaders and also the project repository on this Excel spreadsheet. I provide the link to this Google spreadsheet on Canvas. Okay, without any waste of time, let's go to, I hope you have all had a great break, and now I'm going to talk about, so I don't think if there's any questions about the first problem in the homework, right? Is there any? We solved this a long time ago, and you should be all done with it. But the second one is a little bit tricky and long. So let's see how we can solve this problem. So the question is this. We have a real data set. This is a real world data set. Like there have been like billions of dollars spent to get this data set by NASA. And now our goal is to extract the information that is in this data set and also in the links that exist on this table on the web. We want to fetch this data from the web and use it and plot the data that is contained in this table, right? So I have made the life a little bit easier for you. You don't need to download this table, which is in HTML, and you will have to parse it, which is a lot of trouble for you. What you need to do is to download this table, not this one, I'm sorry, the one that's given here. So this table, you see, its name is triggers.txt, right? And it resides in this link, shawmyer.org, ICPF, homework 5 problems. Okay. Now our goal is to read this data, which contains a set of numbers. These are IDs, these are not really numbers, because you see there are zeros, leading zeros for each of these numbers. And these are IDs of the events that NASA has detected using their Swift satellite. And our goal is to download the properties of these events from the web and then plot the two properties against each other. So these events have two properties. They have one property called fluence, which is this here, and the other property called E-peak, or the peak energy, right? And now, if I wanted to give you an idea of what these mean, this one is the total brightness of these events in the sky. So if you look at the sky, you will see an event there occurring in the universe, and then if it's too bright, it will be on this side. If it's not really bright, very dim, then it will appear on this side of the plot, right? And this one represents the color, not really the color that we see in our real life, but basically, let's assume that you can codify the color and represented by numbers instead of different colors. So from red to blue, you would represent every color with a number. Okay? So you have the rainbow, and you convert the rainbow to a set of numbers. Then this E peak represents the color of the event. So you could look at this guy and you see a blue event, which is very bright, so that will appear there, over there. And you see a dim event, not so bright, and reddish color, then it will probably be around this region on the spot. Okay. So each event has these two properties, and now our goal is to download the information about these events and then plot them all together on this plot. So there's about like I think this table contains 1,040 events, I think. 40 of these events that occur in the sky. But the problem is multifolded, because some of these events do not have any information, do not have any color or brightness. We just know that they occurred somewhere in the sky, but we don't have any information about them. So we have to deal with these sorts of inadequacies in the data set properly using MATLAB. So now let's first do this. So let me tell you a few more things. Now, corresponding to each ID that I have here, I can go and download the information for that ID from a link, for example, like this one. So this link, so all the information that we want about this data set has been taken from NASA website and put on my own website, because I didn't want to create excessive traffic on NASA, despite the fact that it's negligible. But basically, I have all the information for you in this web address. You see it at the top. Unfortunately, I cannot really enlarge it anymore. But this is the web address. This is the data repository, online data repository. And then this is the file name for the event ID 00745966, and then underscore the properties that it contains. It contains epeak and fluence, okay, the two properties. So our goal is to construct these web addresses from the IDs that we have in that file, and then go to these addresses using MATLAB online and read this data set for each of these events. Okay, so I have done this already in my own computer. So you see the list of all files that we have. So each file, I hope you see it well. You see it starts with GRB, which is the name of the events that occur in the universe. So we call them gamma ray burst, GRB. And then the ID of the event, which is 00306757. Okay. And then just the two properties that appear on the text file. So if you open the text file, you see two columns. The first one is epeak, and the second one is basically the fluence with a different name. Okay, and this data set represents the uncertainty about each event in the sky. So for example, when we see an event in the sky, we don't know exactly what color it is. We say it's probably close to blue, green or blue, somewhere like that. So because of that, because we don't know exactly the color and the brightness of these events, we get a set of numbers. So we say the color of this event is in the range 403 to 7,504. Okay. So for each event, we don't have just a single number. We have a range of numbers, and that's why you see this scatter plot here. For example, this is one event, but you see it's a spread over a range. It's not a single dot there. Okay. For example, this is another event, but it's very vague in this color. So people, when they saw it, they said probably we cannot really determine its color exactly. So its color is probably from here to here, right? But its brightness is relatively well constrained, so it's in this range, right? For some other ones, it may look in another way, right? So now our goal is to read all these data sets in these files and then plot them all together. So this is what we wanted to do, what we want to do for problem number 2 in homework, right? And then eventually we should get this plot once we have downloaded all the data and plotted using MATLAB. So how do we handle this problem? There are multiple sections. First, we have to read the IDs of these events, right? So I told you that there is this list of IDs here. So we have to write a MATLAB code that goes to this link online and then reads all these IDs and then creates individual IDs from this, the content of this file for ourselves. Okay. So that's the first part. The second part is to put these IDs in a web address and then use that web address that we have created in MATLAB to go to the online address that contains the information about that ID that we have created, and then download that information, save it locally on our own desktop. Okay, and then once we have done this for all of the events in this list, then we are going to open them one by one and then plot the results on top of each other in a single MATLAB plot to get what we have here. Okay, so 3 parts. Read the trigger list, this one here, all the IDs, and then construct the web addresses corresponding to the data files, and read the data files, save them locally on the computer, and then third, read again all those files that you have saved locally on your computer, and plot the result. Okay, so 3 parts. Now let's go to the first one. I want you to also open to your MATLAB and try downloading these files yourself. Okay, so let's go to the problem again once more, see what we want to do. How many of you have solved this problem, by the way?
I have a question on this.
Yes.
How do you just leave zeros? Because F and F gets rid of them.
How do you get rid of zeros?
No, how do you keep leaving zeros?
Oh, they're leaving zeros. Okay, that's a very good question. I remember I had this problem myself when I was writing the solution for your problem. The solution is to. So when do you need them? That's a question.
Because I mean, it's the ID, right? You
right.
That back in the lane.
So let me see. Let's go step by step. We'll get to that problem for sure, because I had it and you have had it. So everybody who's going to solve this problem will have it. So let's solve it step by step and see where it appears. So the first step: write a MATLAB script named fetch data from web that uses this web address to read a list of all GRB events, and then writes a table trigger list on a local file for you. So how do you read information from the web? Okay, I want you all to open the MATLAB session and read this data from the web right now and save it locally on your desktop, because the homework due date is on Wednesday, right? So let's get rid of this problem and understand it fully today. So let's try it. I have a variable. Do you see it well? I think this is too small, right? I think I don't need this. I can just... Okay, now it looks better, I think. Okay, so I have this address from which I want to read the information. So this is the trigger list URL, which is equal to this string. Okay, now I want to create, so I want to read the information in this web address. So what I say is, what is the function that you can use in MATLAB to read the information from web read, right? The good thing with MATLAB is that the function names are really straightforward and understandable. So I want to read the information and name it trigger list. Okay, maybe I will capitalize the first letter, and then this is the trigger list URL. Okay, now let's run this and see what we get. The requested page does not exist. Is that an old message or CLC? Okay, now let's try it one more time. Okay, let's run it. Okay, so now if I say trigger list, I've created a variable that contains all of the IDs. And the thing is that if you look at this, if I say what is the class of trigger list, it tells me that it's a character. Okay, so now see, trigger list is a character. It's a vector of characters, right? But we want the individual IDs in trigger list. How do we get the individual IDs? Because right now they are all attached to each other in a sequence. So how do we separate them from each other? Any ideas?
Make them an array.
How do you make an array of it? Because it's a string, right? It's a long string of all numbers. So if I say, what is trigger list 1 to 30, it's going to print all of these IDs together, including some random numbers at the end. Yes? That's one solution. You could say, no, if what do you say? Like you say, convert this long string to a number?
Yeah.
It wouldn't work. Let's try it on this one. So I would say str to num. So str to num, what does it do? It converts a string to a number, right? So it removes the leading zeros, right? I think that's a problem you had, right? So that's not the solution.
Okay.
I think probably when I was trying to solve this problem, I tried your solution. It didn't work. There's a smarter way of doing it, solving our problem. So that smart way is this. If you look at the string that I have here, so this one, you see that each ID is printed on a separate line. What does this mean? This means that there is a new line character at the end of each ID, right? So right here, you don't see it because new line character is not visible, but it exists. What is this symbol for it? /n, right? So this is the new line character. So /n. Okay. Now what I can say, it exists there, but we don't see it. But I can use it to split all these IDs from each other. Okay. So I could say trigger list equals str split. What does str split do? Very clear, right? Splits a string, right? So what do we want to split? No, we want to split the trigger list. This is our string. And how do we want to split it? We want to split it wherever there is a new line character. Okay. Now let's try this and see what happens. Okay, now let's look at trigger list and see what we have. You see, it becomes a cell array of all the IDs, individual IDs. Okay, which is really good. So now if I say class of trigger list, what should I get? It's a cell, yes. And then if I say trigger list 1, the content of the first element in trigger list, what is it? It's a character of numbers. So what is it really? If I print it, you'll see that it's a character of numbers. It's the ID of the event, the first event in this list, in this long table that we had. What is the length of this? Length of trigger list. It's 1019. So there are 1019 IDs or events in this file. Okay. So now we have solved our first problem. So we have got all the IDs that we wanted. Now our goal is to construct web addresses from these IDs and go to those pages and download the data sets that exist there. So how do we do this then? To solve this problem, you have to, so the best solution is to define a data repository. So data repos is the base of the web address that contains the information I want. It's here / what? Swift. So if you go back to and look at the one of the files, for example this one, this is the data for the first event. It exists in this web address, seanwright.org, ICP 2017F, homework 5 problems, Swift / the name of the file. Okay? So now this is the data repos, and now I want to create the file name. So let's take the first one. If you're working with a problem, always try to simplify your problem and work with a simple case, and then when it works, then you generalize it to all other cases. For example, here you have more than 1,000 IDs, events, right? So you need to download probably about 1,000 files from the web, right? This is tremendous. So you don't want to do this all at once, because there will be a lot of problems. So let's try it for one single file, one single ID, and then when it works, we'll generalize it. We'll put it in a for loop, and we will do it for the entire IDs in this list, right? So let's do it for the first one. So I say I equals to 1, corresponding to the first ID, okay? And then I say file name equals, if you look at the names of the files, you see that it's grb, the ID of the event, _ep _flu.txt, right? So we want to create this file name. So I say grb, I have to concatenate the strings. So I say grb / what should go here? The ID of the event, right? How do you get this?
Why are we using brackets?
Oh, brackets. What does the brackets do for us? What? Concatenates. What does concatenation mean? It puts together the parts of a string, right? So if I say mir is some guy, what would happen? You get it all in a string. Okay. So now again, back to our problem. I have grb, and then what else do I want to add here? Trigger list. So I'm confusing different languages with each other. I was writing in Fortran for a second. Trigger list. The first one, I is equal 1, right? So we want to test this code for the first event, and then when it works, we'll generalize it to all the events in the list, in the trigger list, okay? And then what's the rest of the name of the file? It's epeak, what else? flu.txt, right? Okay, so now we have created also the file name. Now I say this URL, or data URL, I would say is more meaningful. Data URL equals what? Data repos and file name. Okay. So now let's look at this and see what we have got so far. So data URL is this, which should exist, right? Because we already tested it and it exists. So let's go to this web address for a second and see if it exists or not. Yes, it exists, right? It contains this information. Okay. Now our goal is to read this data set and then plot it eventually, okay, for all of the events. But here's the thing. For some of these events, this web address, this data file that we are searching for does not exist. How do we catch these problems? Huh? Try catch, exactly. So again, MATLAB is very straightforward. So if you want to catch an error, then you use try and catch block. So what is a try and catch block? I have it part of the lecture, I think lecture 11, about the try and catch block. It basically helps you to avoid breaking your code abruptly without any prior notice. For example, let's read this web address for a second, and then I will tell you what's the value of try and catch. So how do I read this data? I would say data equals web read data URL, right? Does that make sense for you guys, what I'm doing? So I'm reading the data contained in this URL and storing in this variable, right? So now if I say data URL, it should work. Okay, now let's look at data. It's again a string, right? But I do not need to worry about the format of this information. So it's all numbers, but it's stored in the format of a string. So if I say what is the class of data, it's a character again, right? But I don't need to worry about this because all I want to do at this moment is to store this file locally on my own desktop, right? How do I save files locally on my own desktop? We have discussed a few methods so far. Can you name a few? XLS write. Other ones. It all ends with write. So just name anything. Text write. I don't think it exists, but it's close. So what other formats do we have? CSV, right? So you could say CSV write. What other method? fprintf. What does F stand at the beginning of fprintf? Does anybody know? File print. And how about the last F? Formatter. So fprintf is a primitive function that actually exists in C, and MATLAB inherits it from C. And what it does is that it can print things for you in a formatted way. A formatted way means that you can have control over every single character that you write in your file. With CSV write or XLS write, you don't have that much of control. You just say write this data in the format of an Excel sheet or CSV file, and you don't care about the rest. But with the fprintf, you tell MATLAB exactly what to write, character by character, right? And this is exactly what we need here, because we have a data set that is all a string, so we want to tell MATLAB to write this file in the format of a string to this file that we want to store it. So, but before using fprintf, I need to open it. So how can I open a file to write? Again, very easy. If you want to write it, you say CSV write. So if you want to open a file, you would say open, right? But that's not exactly what we want. We want to open a file, right? So you would say fopen. So I say FID equals fopen file name, and then what is our goal in this opening of this file? We want to write into it, right? So we want to write information in this file. So I say our intention is write. What if we wanted to read information from this file? I would say yes. I would say R instead of W, right? but we want to write, so we keep W. And then, what is the meaning of FID? It's just a variable. So I can try it and see what happens. So if I say, open this file, it's going to print FID equals 3. What does this mean? FID is a variable of my own definition. So I have named it FID because it stands for file ID. It's just a variable of my own choice. I could name it whatever I want. But the content of it is always an integer that points to the file that you're working with. So whenever you want to work with a file, either you want to read it or write it, doesn't matter. What you do is that you use fopen to open the file. And then what fopen does is that it assigns an integer to that file for you. So whenever you want to point to that file and say, hey, go write in this file for me, you don't name the name of the file. You just say, go to this integer number which points to this file and write information in that file for me, right? So that's the usefulness of FID. Okay, now I say fprintf. How do we use fprintf? Does anybody remember?
The file ID in
Yes. So we say the file ID, write it into this file with this file ID, FID, which is 3. And what is the format of the? Is it? I think the format goes the second, right? So what do we want to write? We want to write data that we just downloaded from the web, right? And what is the format? It's all a string, right? Data is a string. So how do I represent a string? I would say, so the symbol that represents the format in fprintf is percentage. And that's the same thing in other languages, almost universally, in Python, C, everything, right? So I want to write this data, the content of data variable, in the format of a string into this file using fprintf. Okay, now I'm done. What did I forget here? I should close the file, right? Because it's open. So if you open a door and enter it and do something, when you're done, you have to close the door, right? So I say close FID. All right. Now let's try this and see what happens. Let's look at the current folder and see what we have. Oh, I have all the files here already. So you won't see it. Well, let's see where we are. PWD, MATLAB drive. Okay. Oh, yes, that's correct. Yes, so we have to use fclose. Again, that's the syntax from another language. Okay, now it worked. Now, if you do this, you will have a file in your MATLAB working directory named file name, which is this, and it contains the information that we saw here, the information, this one, right? So that's all done for one single event. Now we want to generalize this and do it for all the events in this list, in this trigger list, right? But here is the catch. So if for some reason the data file that you're looking for doesn't exist on the web, what would happen? So let's name this to something else. I don't know. Let's just name it unknown. So this file doesn't exist anymore because so if I now redefine the file name and the URL, now data URL is data URL. What happens? Oh, it's okay. Yes. So data URL is now this. It has an extra name in it, and if I copy paste this name, it doesn't exist on the web. Just to prove it to you. Page not found. Okay. So let's see if we try to read this file from the web, what will happen. Data equals what did happen? It says the server returned the status 404 with message not found. That's exactly what we saw here, right? Look at this, 404 page not found, right? So if you have this in your code, what will happen? Your code will break abruptly and will not continue through the rest of the work. So it will stop right there. And that's not good, because the file doesn't exist. Who cares? We want to go move to the next file, right? We want to be as automated as possible and not to be stopped by these sorts of problems. So how do we solve this problem now? If this error occurs, we want to tell the code, skip this file because it doesn't exist, and go to the next one, right? So how do I do this then? I could put when I want to read the data, I could use a try catch block. I say try data equals this and catch. If any error occurs, you could also specifically tell MATLAB what kind of error. If it occurs, then do what. But for us, at the moment, there's only one error, and it's that the file doesn't exist, right? In that case, print a message. Say, display the requested file does not exist on the web. Skipping. Okay. And then end. Try catch end. As simple as that. It's just like if block. But you cannot do these things, do the fancy thing that I'm doing with try and catch using if block. Because if block will break your code. Again, if the error occurs, you cannot do anything with if block. But with try and catch, if an exception happens, basically the error is called exception, right? It's an exception, the file doesn't exist. Then we can handle it very nicely and gently and say, MATLAB, ignore this problem, ignore this error, and then go to the next one. We don't care about that missing file, right? So let's run this code again and see what happens. CLC, right. Now, test2, the name of the file. The requested file does not exist on the web, skipping. Why doesn't the file exist? Because the file doesn't exist. Right. So now I could add another message. The file exists on the web. Not skipping. Okay. So now let's try this. And now note that I changed the name of the file to the correct name. Okay. Now let's try this. The requested file does exist on the web, not skipping. Okay, but this is redundant information. You don't want to print 1,000 times that the requested file exists, right? So I want to remove this display message, which is the most useless message of all time. So only we will print it when we have a missing file, right? Now I can also add a counter here to count the number of missing files, right? So I could say missing file counter equals 0 and missing counter equals missing counter plus 1. So whenever an exception occurs, the file doesn't exist, add the missing counter, file counter, add 1 to the missing file counter, right? And then I could also print it. Say display total number of missing files is num to str. What does num to str do? Converts a string, a number to a string, right? That's how you should represent numbers in a display. Okay. Now if I do this and save it, So I initialize the missing file counter to 0, and then whenever there is a missing file, I add 1 to the missing file counter. Okay. Now, what did we forgot? If you run this, I could also print the message and say total number of I want this message also to be printed at the end. Okay. Now let's run this code and see what happens. Total number of missing files 0. Now if I change it to some other name, unknown, then total number of missing files is 1. Okay. Now we did this all for one file. That's not what we wanted to do. We wanted to do it for all the files, right? So now we go back to the original problem that we had. We solved the problem for a simple case, for only one ID, for the first ID. Now what do we need to do in order to do it for all the IDs? What's the solution? And use a for loop, exactly. So instead of defining I to be 1, I say for I equals how far I should go, length of, no, you always try to avoid hard coding, because some other time this data file might be updated with a new set of IDs. Then that's exactly what happens with NASA datasets or anywhere else in the world, in any other data set. The data sets are updated automatically every day, right? So you will get a different length of IDs every day in this file. So you want to say go through all the files, all the IDs. So you want to go through all the IDs, and that's the length of the trigger list. That contains the list, list of all the IDs, right? So I say for I equals 1 to length of trigger list, do everything that we have done so far. Okay. And now we don't need this message. I don't want to. Excuse me. Now, thank you. What's the last part? Just say end. So end the for loop and then print the total number of missing files at the end, once you have read all the files. Now let's run this code. For loop. There is something missing, you said?
There's a semicolon.
Semicolon. Oh, I see here. Okay. Now, thanks. So,
Yeah, why can't we have a semicolon?
it's not necessary. You can have it, but it's not necessary. Right. You see, it didn't give an error. It said, it just gave a warning and said, like, you don't need this. It's redundant. Okay, what's the question? It's good for your own information to see how many files are missing. I think there is probably around 100 files missing. So we could also make it more informative, because it may take long on your computer. So you could also add a message here and say fetching file This is really good, because if you have a lengthy code that takes a long time, you want to know if your code is really doing something useful or is just wasting time, looping forever for eternity for doing nothing, right? So it's good to add a message that keeps you updated what the code is doing right now. So I say here, I say when you want to read the data from the web, say fetching file number, and then here I print I. So it's the first file, the second file, how many files. I want to know how far I have gone in this for loop, right? What does it do? Okay, now it should be working fine. So now let's CLC, close all, clear all. I want to clear everything. CLC again, and then test 2. It's going to take a while, probably a few minutes. So now let's see what happens. Okay, there's a problem. Undefined function or variable data. Ah, I see. So if the file doesn't exist, see, there is a missing file. So the problem was that if the file doesn't exist, we don't need to open a file locally to write the information, because there is no information. So this file open should appear with the try and catch within the try section of the code. Okay, so this now makes sense. So try reading data from the web, and if it exists, then open the file, write the information locally to a file, and then if the exception occurs, then catch it gracefully and then go to the next file. Now let's run the code again. CLC test2. You see, it's going through all the files really fast. Go ahead, please.
Is there a way to store all these files in a separate folder?
Yes, you could, instead of using file name here, you could say store it in a concatenated string. So store it in, I would say something like this. So, for example, we could store it in Swift folder and with this file name. Okay? But then, here's the problem. What would happen if the Swift folder already doesn't exist in your MATLAB working directory? So you'll get an error again. So you should create it first, but a more clever, a smarter way of doing this is to ask your code to do this for you if the folder doesn't exist. So your code should be smart. You should not leave anything, any burden on the shoulder of the user to do, right? So this is the folder that your code needs, so your code should create it itself. So what I can do is that I can say data dir here, create a variable, data dir, and then go to the top. Before the for loop, I say data dir equals this string. And then I say mkdir data dir. So every time I run this code, it will make sure the directory exists or not, and if it doesn't exist, it will create it for me before writing the files into it. Okay? So now let's try it again. Oh, it read all the files. That was fast. Okay? So, but there's a problem with our counter. It says the total number of, I think the problem is what? Yes, because I reset the value of the missing file counter each time I run the for loop, right, inside the for loop. So I have to initialize the missing file counter outside, right? That should make sense now for you. Does it make sense? Any questions so far? Yes?
Where did you reposition the FID and active counter?
Oh, you have to put it inside the try block, not the catch block, or outside of it. So you try to read the data first. If there is no error, then you open the file, store the information in a file locally, and then close the file. And if any error occurs, then you go to the catch section. Say, catch this error, and so on. Right? So we're pretty much done with our time, but we have done the difficult part of the problem. Now let's run this code again. I want to make sure that everything works fine. CLC test2. Okay, it's going through all the files, and you see now it is storing the files inside of a directory called Swift. So it creates the folder if it doesn't exist, and then it stores the files inside of this folder. So let's go up again. Here is data dir. Okay, and then we make the directory data dir and store all of the information there. Now the last part is to again loop over this trigger list and reread all the information from these files using table read. Okay, so I want to give you a hint. If you cannot make it to my office hours today, do you want more time for this homework, or you're fine with Wednesday? Okay, how about Friday?
Yeah.
Is that good? Okay. Again, our goal is not to give you grades, to learn something. So you can extend it as long as you want. Yes.
It says they were all missing.
It's okay. Bad. That's bad.
Oh, you still have unknown in file.
Oh, I see. Yes, that's why it's missing. Okay, now it should work. Good catch. Thank you. So it's not working. Look at this. This is beautiful. All right. So yes.
What if you do data here and include here?
If you want to store all the files locally in a different folder, you could create a data dir variable that is the name of the directory that you want, in which you want to store the information, and then you say create this directory if it doesn't exist, just to make sure that it exists. Otherwise, it will give you an error if it doesn't exist.
Okay, and where did we have to add the?
And then you say the file name that when you want to open the file, you say open the file in this directory with this file name with the intent of write.
Okay.
Right? And then everything else is the same. Okay, so alright guys, I will see you on Wednesday and 40. Remember, I told you that I'm extending my office hours from 3 to 5 on Mondays and Fridays. And again, for the project, you have about more than 2 weeks, 2.5 weeks, and I think that's enough time for all of you, for all of the teammates to excel and do it completely. So come to my office hours, and I will help you with the project. We'll also discuss it throughout the class in future.
When I search for like schedule, like the username, it still shows up as if like every time I get files in files, but there's no so like by the last after the last class, it says like a date.
Don't worry about the date, but they're not. Don't worry about it.
I'm just giving you an error when you're trying to go to the Swift folder.
Yes. It says invalid permission. Okay, so you probably cannot go to this folder.
In the, like I'll open it to my computer and my MATLAB.
So you have,
Yeah.
yes, and then error using F open.
It's just like once it's done, then you.
So, oh, you see the problem? It says, don't forget the concatenation bracket.
Oh, okay.
You see, you cannot give it multiple arguments.
Yeah.
So you have to put the.
Is the quiz on Wednesday or
Oh, there will be a quiz on Wednesday, but it's going to be really easy. Don't worry about it. And I will tell you about it on Canvas. So I will send a message to everyone today. Yes, sure. Hey, Jack.